Okay, so we are in actually bottom-up parsers, and we have already finished two of the bottom-up parsers. So it is like this. So we have uh, DUP bottom-up parser. It is also called SR parsers. It is divided to two broad categories. One is actually called operator precedence parser, and there is a big genre of parser which are most important. That is called LR parsers. Then we subdivided the LR parsers, and we get four big categories: LR0, SLR1, then LALR1, and CLR1. We know this number. We know this number. This number is nothing but look ahead. These are nothing but look ahead. Then we also deep inside this LR parsers, we understand LR0 and SLR1. It used a special type of item which is called LR0 items. And we also coined another thing that LALR1 and CLR1, it uses a special item which is called LR1 items. For understanding the items, we have talked about two special operators. We have talked about two special operators. One is called closure, denoted by a dot, and we have also talked about another operator which is called goto. It is denoted by this arrow mark. So what is closure? Closure is nothing but what has captured so far and what are you what are we expecting? So this is very crude idea about closure, and go to is move on, move on, move on, terminal or variable. And we also further discuss move on terminal. We also call it shift. We call it shift, and move on variable. It is generally called go. Shift, and what is shift? Shift is nothing but a push operation. So definitely, this all parser use a stack. In fact, all these use parser use a stack. Operator precedence parser use actually the OS stack. No, I'm not right. So actually, I should say all these parser use stack. So you have to create your own stack data structure. So that's the brief gist of all the bottom-up parsers and all the classifications. Now, let's talk about LR0, LR0 and SLR1. LLR1, 1, CLR1. All these parsers, parsing algorithm is same. Am I right? Parsing algorithm is same in all these parsers. So no difference in parsing algorithm. Even uh, even the table is also same. Parsing table is also same. also same except in reduced part. And what is reduced part? Can you tell me what is reduced part? Anybody? What is reduced part? This. What is the reduced part?
Yes.
Yes. What is the reduced part? Tell me. Come on. You have exam just 2 weeks after. Nobody knows what is reduced part. Can you listen to me, guys?
Sir, sir, it is popping from the stack.
You cannot listen to me?
Sir, yes, I can listen to you.
Then what is reduced part? Samira?
Sir, pop from the stack.
Not
Sir,
only
rules গুলো বলছেন, rules গুলো বলছেন।
reduced part. What is reduced part? Reduced part means it is the rules. It related with rules. But when we reduce, it means closure operator is at the end or uh, at the end or it sees everything of RHS of a product. In other words, to reduce right hand side to left hand side. So this is the only difference in all these parsers. Now in LR0 parser, why should we write the, let's number this 1, 2, 3, 4. So why should we write the reduce move actually in LR0 parser? Come on. Huh? Why should we write the reduce move in LR0 parser? Entire row of
Entire row of shift or action.
action. Entire row of action. So that is the LR0. Now, number 2. Why should I write the reduce move in SLR1 parser?
Follow of
Follow
LHS.
of LHS of a product. Now, the big question. Number 3, why should I write the reduce move? And number 4, why should I write the reduce move? That is the difference. So this is the difference. And this is the similarity. All right. So before starting these two parcel, LLR1 and CLR1, you need to know what is actually LR1 item. We need to know. We already know what is LR0 item. We need to know what is LR1 items. So let's start. What is LR1? So what is LR1 items? LR0 item, LR0 items plus look aheads. Together they are called LR1 items. Together they are called LR1 items. For example, let's give you an example. Let's assume A derives, just take an example. A derives, let's say alpha dot B gamma. Then B derives dot beta. Okay. So what is this called? What is this called? This one? What is this called? Where, let's say, where A comma B belongs to variable and alpha, beta, gamma belongs to terminal. What is this called? What is this called?
The rule.
Each one is a rule, but what is this called? The whole thing is called
Closure
State.
the whole
grammar.
thing is called whole thing is called state, a state or closure. Good. And each one is called what? Each one is called what? This one, this one,
Rules.
not rules. They are called actually LR0 item. They are called LR0 items. Now see, so this whole thing, this whole set is a state of the diagram or closure, and each of this part is called a LR0 item. Each of the member is called LR0 item. Now, what is LR1 items? LR1 items is something like this. A derives alpha dot B gamma. Not only that, after that one, there might be some sort of look ahead. There might have some sort of look ahead. B derives beta dot C comma D. So this is again a state or closure. This is again a state of closure where A comma B belongs to variable, alpha, beta, gamma belongs to terminal. But in this case, this whole thing, or this whole thing, they are no longer LR0 item. They are called LR1
LR1 items.
item. Now just take only one LR1 item. Let's take this one. A derives alpha dot B gamma. A or B. How about up to this part? What is this part? This part is what?
LR0.
This is nothing but LR0. But we also added something more. This one, which is nothing but look ahead. Together, they become LR1. Is it clear to you guys?
Sir, the L look ahead part isn't clear to me. Like,
Okay, because it is not clear. It is not clear to me because I did not show you how to find look ahead. When I show you how to find look ahead, it becomes very easy. We don't know yet how to find look ahead. Just think there is something called look ahead. Don't be too much fast, then it's a problem. We
okay,
have to
sir.
keep pace with other students. Somehow there is some sort of look ahead. Just remember. We don't know right now how to find the look ahead. But remember there is a look ahead in LR1 items. Now the question is how can I find the look ahead? So let's take an example. And we have solved this example many times. We have used this same grammar for LR0 and SLR1. So let's take that grammar. What is that grammar? S derives A derives small a, capital A, or B. So let's take this one. So what is the first part? What is the first part? Say,
Augmented.
adding an augmented product so that I can start from S, capital S. So S dash derives S. Okay. Now start applying the rule. So S dash closer capital S. Now, as it is the start symbol, always remember, as it is the start symbol, initially after the start symbol, initially after the augmented product, always the look ahead will be dollar. That means the end of the buffer. Did you get it? It is a rule. All right.
Yes, sir.
Always remember, for augmented product, when you apply the closer, always it starts with look ahead dollar. Then what is after closure operator? What is after closure operator?
S.
Capital S.
Yes.
So I have to add all the products start with capital S. So S derives. Here I have to apply closure operator because this is the product start with S. So after closure there would be capital A, capital A. Now what would be the look ahead? Now the look ahead would be, why did you add this product? Why did you add this product? Why did you add this product?
A.
Why did you add this product? S derives double A, double A. Why did you add this?
Because
product?
after
Because
closure there was an S.
in the previous step, just after closure there is a capital S. Am I right?
Yes, sir.
Yes, sir.
Now, what will be the look ahead of this? You go to previous step, you discard the symbol. Whatever left after the symbol, first of that part is called the look ahead of the next item. So what would be the just after the capital S?
Dollar.
Dollar, because there is nothing. You can consider this is epsilon and this is dollar. So first of epsilon dollar is nothing but dollar. So you have to add, look at here, dollar. Did you get it? Okay. Now, what is after this closure operator?
A.
So I have to
A.
add all the products start with A. So A, then I have dot small a capital A or dot small b. Now, what would be the look at for these two rows? Am I right? So why did you add this product? Capital A derives small a or B. Why did you add this product? Or why did you add this item? Because after this closure, just previous step, go to previous step. What is just after this closure? There is a capital A. That's why I have added this one. So what would be the look at for this? You go to previous step, you add this product because of this A. So discard this A. What is just after A?
A.
A.
A, don't say only A, say whole things. Capital A,
Capital A.
semicolon, dollar. So you will find first of this entire part. So what is first of this?
First of A.
First of A, and which is that? It is nothing but A comma.
Small A. B.
So here look at would be A comma B, A comma B. Then just after this closure, there is a terminal. Just after this closure, there is a terminal. So you have to stop over there. Then it has become closure. And each one is a LR1 items. Did you get the point? Done?
Yes, sir.
Sir, can you
Okay.
explain the look ahead again of A?
Which one? Just go to this one.
Right.
Why did I add this product?
At A.
Because of the previous items, so after closure, there is a capital A, right?
Right.
So if you want to find the look ahead for this item, then you will discard this one, this A. Then what is just after this A, you are considering that part. You are considering this part. Capital A, semicolon dollar. You will find first of that. Don't worry, I'm going to give more example. You are going to see. It is getting clear. Then, if you go to on capital S, what do you get? S dash derives. S dash derives. Capital S, closure.
Dot.
And when you apply go to, don't change the look at. Whatever the look at before, you are going to write the look at. Okay? All right?
So can you repeat the last
If you
sentence?
if you apply the go to operation, don't change the previous look at. Whatever is the look at, just write that look at.
Okay, sir.
Now, move on capital A. If you move on capital A, what do you get? S derives. Capital A, closure, A. Then don't change the look at. What is the look at previous? Dollar. So right, dollar. Now, what is after this closure?
A.
Capital A. So you have to add all the products starting with capital A. So you have to write again A derives, small a, capital A, closure at the beginning, and closure B. What would be the locate for this item? Why did you add this product?
So
Because of this A.
A.
Am I right? So discard this A, whatever remaining just after that one, first of that one. So what would be the locate?
Dollar.
Dollar,
Dollar.
and this one would be dollar. So we are done because just after closure there is a terminal. So it is another item. Now let's go over here. Let's move on small a. So if you move, that will shift on A, small a. So what do you get? A derives small a,
Small a closure, capital A.
closure, capital A. Don't change the look ahead. So look ahead will be a comma. Now, what is just after closure?
A.
Capital A.
So I have to add again all the products starting
Capital
with
A.
capital A. So AA or dot B. Now what would be the look ahead? You add this product,
A,
A or B.
or B.
add this product because of this one. So discard this one, whatever remaining first of that one. That is nothing but A or B, A or B. So you are done because now just after closure there is this terminal. So you have to stop. Okay. Now let's go over here. Go to shift on B. What do you get? A derives B dot, and it's a final item. So you have to stop and don't change the loop ahead, which is nothing but A comma. All right. So do you have any question? You can ask. No question? There. Now let's number this 0. This is 1. This is 2. 3. Now let's start again. Now go to on capital A. What do you get? What do you get? S derives. S derives. Capital A dot is the final item, and it is a go to move, so don't change the look at. Stop. We are stopped here. Now shift on small a. What do you get?
3.
You get A
Street
derives. A derives. Oh wait, there is a catch. Wait. A derives small a dot A. Then again, just after closure, there is a A. So you have to add all the products starting with A, small a, or dot B. You are right. If you don't consider the look ahead, this is same. Am I right?
Yes, sir.
If you don't consider the look ahead, this one and this one, these two are same. My index finger, left index and right index finger stay. They are actually same. But if you consider the look ahead, then you have to think again. And that is the difference. If you are in LR0 or SLR1, no problem, because there is no look ahead. They would be same. But now you have to consider also the look ahead. Now what is the look ahead for this? For this one, this shift
Dollar.
move, the look ahead does not change. So it would be dollar. Definitely this is different. Because the first item, the look ahead is A comma B. Here the first item look ahead is dollar. Did you get the point?
Yes, sir.
Yes, sir.
So that is the difference. It is LR1 items. It is no longer LR0 item. You have to also consider look ahead. Because of look ahead, they are different. Now let's fill up this. Why did you add this? Because of this A. So discard this, first of this. So dollar and dollar. Done. Did you get the point?
Yes, sir.
Okay. Now shift on B. What do you get? A derives B dot. Again, you might think that, oh, this one and this one, my index finger, this one and this one is same. Yes, if they are actually LR0 items, they are same. But because we are not considering LR0 items, we are also considering LR1 items. So we have to also check the look ahead. Now, look ahead is different. Here it is dollar. Did you get the point?
Yes, sir.
Okay, all right. Now let's number this. This one is 0, 1, 2, 3, 4. Let's call this 5. The final item. 6, 7. This is the final. All right, so let's start again. So we are done. Let's go to number 3. So go to on capital A. What do you get? A derives small a, capital A, dot, dot. So it is the final item. We have to stop there. And look ahead does not change. Now, if you move on B, what do you get? Sorry, if you move on small a, what do you get?
Small a closure
Tree
A,
itself.
And what would be the look ahead?
A and
A
A
or
or
B.
B.
So then we are actually again come back to same state. Now it is fine. Did you get the point? Now it is
Yes,
fine.
sir. It's
And on B, what do you go? We are going to here. We are going here. Done. It is done. It does not create a new state, so it is all right. Now let's go to here. It is done. It is done. It is done. Let's go to here. So only no new state has been created. This and it's a final item. So go to on capital A. What do I go? A derives. A derives. A derives. Small a, capital A,
closure
closer. Then what
dollar
would be the item?
Dollar.
What would be the
Dollar.
look ahead? Dollar. So it is different. So we have to create a list. All right. Now over here, go shift on small a. I am getting a derives small a dot capital A. But look at this same. So I am revolving to same state. And B, I'm going to. Now we are done. So this is the LR. This is the LR1 items transition diagram. Do you have any question you can ask? Any question?
not right now, sir.
Okay. Now we are starting. So we are done with LR1 items transition diagram. Now we are starting CLR1 parsing. So the difference is in CLR1 parsing, let's go back here. In LR0, the reduce move is on entire row of action. In SLR1, follow LHS of a product. In CLR1, can you guess why should I put the reduce move? Can you tell me? Any guess? Any guess? Any guess? Only on lookouts. So in CLR1, we put the reduce move on lookouts only. Did you get the point? So let's draw the diagram. Then it will become clear. So let's draw the diagram, it will become clear. How many states are there? How many states are there? How many states are there? Up to 10, 9. So like this. Zero, 1, 2, 3, 4, 5, 6, 7, 8. 9. Yes. This one is my action. And this one is my go to. What would be in my action? The terminals. What are the terminals here? Small a, small b, dollar. What are the go to? S, A. Okay. Now tell me, you are going to fill the table. Zero seeing small a. Where should it go? Zero seeing capital S. Why should it go? Let's start with capital S. Why should I go?
1.
1.
State 1. Zero seeing small capital A. Why should I go?
Sir, blur হয়ে গেছে স্যার।
ভালো হয়ে গেছে? Just circle the. Yes. Is it all right now? Is it fine now?
No sir, same sir.
Same.
Okay sir, it's fine now.
Okay.
Yes sir.
Now, zero seeing capital S. Why should I go?
2.
Zero seeing capital S. Why should I go?
1 sir.
State 1. Zero seeing capital A. Why should I go?
Take 2.
State 2. Zero seeing small a. Why should I go?
3.
What would be the action?
Heavy.
What is A? Shift. So S, S3. Good. Zero seeing B. Why should I go?
Shift 4.
Shift 1. Anything else? 1, 2, 3, 4. We have done. Let's get to 1. 1. So this is the augmented product. It means it is the accepting state on dollar. So we are going to write here accept. Now let's go to 2. 2 seeing capital A. Why should I go?
5.
5.
State 5.
State 5.
2 seeing small a. Why should I go?
6.
State 6.
6, and it is actually a terminal. So it is action. So it would be a 6.
Shift 6.
2 state 2 seeing B. Why should I go?
Shift 7.
Shift 7. It is action. Good. So 1, 2, 3 done. Now let's go to 3. 3 seeing capital A. Why should I go?
8.
Take 8.
8.
3 seeing small a. Why should I go? Self. But it is
Shift
action.
3.
So
Shift 3.
shift 3. Now 3 seeing small b. Why should I go?
Shift 4.
Then 3 is done. 1, 2, 3. Now let's go to 4. 4 is the final item. We are going to fix that out later. Let's go to, it does not have any shift now. So let's go to 5. 5 is also a final item. It does not have any shift now. So we are going to fix that. 6. 6 seeing capital A. Why should I go?
State 9.
State 9. Then 6 seeing small a. It is action to save. 6 seeing B. Why should it go?
Shift 7.
1, 2, 3. Yeah. 6 is done. 7. Where is my 7? 7 is the final item. Does not have anything. 8 is the final item. There is nothing. Shift 9. 9 is the final. Now, this procedure is same to all the parsers. We know that. LR0, SLR1, CLR1, LALR1. No difference. Now, why should I write the reduced move? In LR0, we write the reduced move in the entire row of the action. In SLR1, we write the move in the
Look ahead.
follow of no.
Follow.
SLR1, we
Sorry.
write the move reduced move on the follow of LHS of the product. Now here we are going to write it on the look ahead. Now let's go to 1 is fine. Let's go to 4. 4, what is the look ahead written here?
AB.
AB. So let's write down this rule, number this. This is rule number 1. This is rule number 2. This is rule number 3. So it is nothing but rule number 3. So I'm going to write
Reduce 3.
reduce 3 only on AB.
AB.
Reduce 3 only on AB. Let's go to 5. So this is which rule? Rule number 1. I'm going to write this rule on where?
Dollar.
Only on dollar.
$1.
So rule 1.
Reduce 1.
Okay. Now let's go to 7. This is again rule number 3. What should I write here?
$.
Only on rule, only on dollar. So going to this column, writing only here. Then number 8. This is rule number 2. Why should I write? Write on.
AB.
A and B.
So let's go to 9. Again rule number 2. Why should I write this rule? Going to dollar
Dollar.
column, writing here. So this is the tip. This is the difference. Did you get the point?
Yes,
This
Yes,
is the
sir.
difference between CLR1 and SLR1. Now, there's a big catch there. In CLR1, now let's say CLR1 transition diagram. Number of states is what? How many states are there in this diagram?
9.
Actually 10, 0 to 9.
10.
Acha. This example I have done for SLR1 as well. So how many how many states are there in SLR1?
7 maybe, sir.
It is actually very simple. You are going to find out. States only differ by, in CLR1, you are trying to find out all the states which have same LR0 items but different look ahead. So how many states are there? How about this? This state and this state. They are actually same, but
The look at is different.
look at different. So 10 minus 1. Because in SLR1, they are actually same state. Am I right?
Yes, sir.
How about this? This and this. They are same state but different look ahead. So in SLR1, they are actually constituted to only one single state. So 10 minus 1. Okay. Now
4 and 7.
4 and 7.
Seven.
They are actually same LR0 item, different look ahead. So in SLR1, they are actually same. Anything else? Anything else?
No, sir.
No, sir. So in SLR1, the number of states would be 7. All right? Acha, in LR0, how many states are there? In LR0, how many states are there? Tell me.
The same is, sir.
কোনটা সমান?
Sir, HLR,
SLR1 is সমান because they have the same diagram. So it is also 7. Good. Very good. Now tell me. Now what happened? We see that in CLR1, number of states might increase. Am I right? Might increase. Now, is it good or bad? 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 Did you remember the last class? We have compared a little bit. If you compare CLR, so might be more states in CLR1 than LR0 and SLR1, and states creates table. Now, which table is shallower?
SLR.
Shallow. What is the meaning of shallow? Which table is shallower? What is the meaning of shallow? Think little bit, then answer.
Not very deep.
More blank entries.
Yes, good. So CLR
So,
percent
CLR.
table, there are
Okay.
CLR percent table, there are nine states. In SLR1 or LR0, there are 7 states. So CLR1 is having more rows. Not only that one, these entries are also getting, the reduced entries are also getting very shallow, because in LR0 the whole row. Now SLR1 has first of LHS. CLR1 right now have look ahead only. Okay. Then this means this reduced entries are also getting shallower in CLR1 percentage. The which table would be more shallower?
CLR1.
CLR1, good. So CLR1 is more shallower. Now shallower means, it means more blank entries. Do you agree with me or not?
Yes, sir.
It has more blank entries. And what is the meaning of this?
Yes.
More blank entries means error handling capability
Increase.
DT is more, number one, because blanks are errors. Blanks are more blanks, more errors. And second thing is less conflict. Less conflicts. Okay? Because more blanks means less conflicts. It is inversely proportional, and it is actually proportional. So which one is more powerful?
CLR.
CLR1.
CLR is more powerful. So CLR is more powerful. More powerful. Both ways. In fact, CLR1 is the most powerful parser in the genre. Did you get it? Alright. So if you get this, but there is a cost. What is the cost? There is a cost. What is the cost? But CLR1 is costly. Why CLR1 is costly? Tell me. CLR1 is costly. Why CLR1 is costly? Any idea? Any idea, guys? Why CLR1 is costly? It is very
Sir,
commonsensical question. More space, good. Because more entries means not entries, more rows. More rows in CLR1. You might say, sir, what's wrong? Entries are less. Entries are less. But the problem is, for blank space, you have to create an entire row. Am I right? It might be blank, fine, but you have to allocate space for that one. Am I right or not?
Yes, sir.
Yes, sir.
Whenever you're creating table, in the table it is shallower. I understand. Those are blank. But for counting the rows, you have to allocate the memory. Must allocate the memory. Am I right? Then you are going to pointing this to arrow. That's fine. But you have to allocate the memory. Am I right or not? That means more space. You need more space. Not only that one, how about this table? How about this table? This table is actually always using. Am I right? This table is always using. We have also parsed lot of actually string using this table, and we have seen continuously we have to contact with the table. What is the entry there? What is the entry there? For that row, that column, what is the entry? So whenever you implement any parser using the code, same thing happening inside the code. The code is always looking for values in the table. That means what? Table is frequently used in parsing. That means what? It will take, what if the table is big, what would happen? The fetching time would be, tell me, fetching time would be,
Higher.
More.
More.
fetching time would be more. So it also creates more delay. So in fact, now let's come to the reality. Yes, CLR1 is most powerful parser in the genre so far. That's fine, but it has lot of drawbacks as well. It is costly in terms of space, and continuously we have to fetch data from the table, so it also time consuming. So that's why we hardly use in CLR1. We use another type of parser which is called LALR1. And can you tell me the tool I have shown you, the lesson here, what type of parser is this? What type of parser is this? This is actually LALR1, not CLR1. So for reducing the rows in table, we use another simpler, comparatively simpler parser that is called LALR. Okay, and lex yak, this do is a LALR1 parser. Did you get it? Now, what is LALR1 parser? LALR1 is very simple. If you know CLR1, LALR1 become very easy. What you are going to do? What you are going to do? Just write this table again. Just write this table again. We have 0, 1, 2, 3, 4, 5. S3, S4, 1, 2, 6, S7, 5. I'm redrawing the table again. S3, S4, 8. Okay. So here I have R3, R3. Here I have R1. I have R3. I have R2, R2, R2. So this is the table. This is the CLR1 table. Now what we are going to do in LALR1, we are merging same LR0 item rows. So did you get it? So we are going to merging same LR0 item rows. So which of these two rows have same LR0 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 item LR0 item? Tell me. So let's go back to diagram. Let's go back to diagram. Let's go back to here. Which of these two have same LR0 item in this diagram? You know the answer. Which one? Huh? Which one? 4 and 4 and 7. They are same LR0 item, but different look at. Tale, we write 4 7 4 7. Whenever I get 4, I'm going to write 7. 4 7 4 7. Then 4 7 4 7. Okay? Then merge these two. Did I have any 4? No.
No.
So merge these two. So I'm going to merge these two. I get there 3. I remove one of this. Then next 8 and 9. They are actually same. Same LR0 item, different look here. So I'm going to write
Yes. 8
8
and 9.
9. 8 and 9. Don't write the reduce mode. These numbers are different. Am I right? These numbers
Yes,
are
sir.
different. They are actually the number of the rules, and these are number of the states. So 8 9 8 9 8 9 8 9 8 9. Anything else? No, sir. Now let's merge this to R2. Remove this. Anything else? I think no. So how many states are there? 1, 2, 3,
7.
4, 5, 6, 7, 8.
8.
এটা আছে যে একটা মনে করা যায় নাকি? এই যে এটা 6 আর 3, 3 6,
6 and 3.
3 6, 3 6, 3 6, 3 6. Now merge these two. S3 is same entry, 8 9. Okay, so remove one of this. Now I have 7. Okay, so this is nothing but LR0, LALR1 table. Did you get the point? Now let's have a conclusion. LR0 number of states and SLR1 number of states. Are they equal or not?
Yes, sir.
They are equal. How about LALR1? Are they equal or not?
Depends.
It
Sir,
depends. Why they'll be different? Why it depends? Why it depends? We are merging. We are merging this number of states.
So the
in-
number of states will reduce.
No, they would never reduce. SLR1, we don't, in SLR1, we are considering LR0 items. In LALR1, we merge the states from CLR1.
Similar item.
So let's talk about this. This one would be greater or equal, might bigger. Now what happened? When we merge merge CLR1, that means LR1 items to LALR1, then what happened? All the states having different locate, they are merging to same. So definitely it would become number of states in LR0 item. So this is also equal. Did you get it? That is the catch. That is the conclusion. Did you get it?
yes, sir.
Okay. আচ্ছা, এবার এটা একটা খুব ইম্পর্টেন্ট কোশ্চেন। If there is a SR conflict in LALR1, can we remove that conflict in CLR1? There is a SR conflict in LALR1. Can we remove that conflict in CLR1? Is it possible or not?
Yes, sir.
হ্যাঁ,
স্টেট পারবে না স্যার, স্টেট পারলে তো স্যার এটা কনফ্লিক্টটা কিভাবে স্যার?
আচ্ছা, এটা একটা কোশ্চেন। Question number 1. Question number 2. If there is a might, can, not always, but somehow possible. If there is a RR conflict in LALR1, can we remove conflict in CLR1? Not always, but is there any example or not? Now tell me, answer of these two questions. Is the question clear to you guys? This is the last question of today. সারাদিন বসে থাকতে পারবো না, অ্যান্সারটা দিয়ে দেন, whatever in your mind. Please.
Sir, question 2 te yes, our question 1 no.
And wonderful, and it is the correct answer. Can you explain?
স্যার কারণ হচ্ছে আমরা সব ফাইনাল স্টেট গুলোকে মার্জ করছি, না ফাইনাল স্টেট না, মানে রিডিউস গুলোকে মার্জ করছি।
ওকে, না রিডিউস গুলোকে মার্জ করছি তো আপনার অ্যান্সারটা কারেক্ট হয়েছে। এখানে 3 আর 6 কে মার্জ করেছে, এখানে কিন্তু কোনো রিডিউস মুভ নাই। মানে আমি
Look
জানি না
ahead.
এখানে কোনো রিডিউস মুভ কিন্তু নেই। তাহলে কেন আপনার এই ধারণাটা হলো আমি বোঝার চেষ্টা করছি আর কি। মানে অ্যান্সারটা কারেক্ট, বাট এক্সপ্লেনেশন আই ডিড নট আন্ডারস্ট্যান্ড। খেয়াল করেন, see, let's assume, just take an example. Let's assume I have a LLR now, something like this. So I have a conflict like this, SR conflict. So it is like this. A derives, let's say B A, and I have another one, B derives, let's say সি, স্মল সি। এখানে লুক এট হচ্ছে আমার let's say a comma b, a. Now what happened? A comma b. Okay, so this is the look ahead. তাহলে why should I put this one, this reduce move? Why should I put this reduce move? I should put reduce move in A and B. Here I should put the reduce move, and there's a shift on A. Am I right?
Yes, sir.
There's a
Yes.
shift on A because just after closure there's a, so definitely there is a SR conflict. No matter how many times you chopped A and B, always you will get a and B. You can chop this product to two parts, like A derives B, A, B derives C, A. This is one part, and another part might be A derives B, A, closure A, B derives C, B. No matter how many parts you chop, there should be always something for A, reduce move, and there is a, you cannot remove the shift move. So there is always SR conflict present in CLR. Did you get it?
Yes, sir.
So that is the reason. Now, just give you another example. Let's assume in CLR1, I have a move like this. A derives alpha dot, which has A derives alpha dot, one place I have move on, look at is C, and I have beta dot B dot beta dot, I have move on B. So it is fine. And another place I have something like this. A derives alpha dot, it is nothing but D. And I have here B dot, B derives beta dot, I have look at C. So it is also fine. These four are separate. Or let's consider this is a single state. Let's make it more easier. This is a single state, this is a single state. So there is two reduce mode. A derives alpha dot C on C, B derives beta dot on D. Here, this is state 1 and this is state 2. There is nothing else. Now what happened? When you are merging this to LALR1, what do you get? What do you get? You get a single state. The state would be ST12. Now what would be the case? A derives alpha dot, it is on C comma D. B derives beta dot, it is also on C comma D. So again, there is a conflict. Did you understand? So in LALR1, there might have a conflict, but sometimes in CLR1, they might be chopped in a such a way there is no conflict. No conflict, no conflict. But there is a conflict. Did you get the point? So this is the reason. Sometimes some RR conflicts can be overcome in CLR. Okay, guys? Do you have any question you can ask me? Any question you can ask me, please. So, in this case also, in CLR1 transition diagram, number of states, yes. So you people understand this, and that is one. And then on merge of. All right, so this is the end of today's class. If you have any question, you can ask me, otherwise I can leave. Any question?
No, sir.
So if you understand up to this, that would be a wonderful headway for compiler construction. It is more enough. It is more than enough for compiler construction course up to this.
স্যার আমাদের কুইজটা কবে স্যার?
Next week, second class.
থ্যাংক ইউ স্যার।
Okay, let's take the attendance, then I'm leaving.
স্যার কিছু হোমওয়ার্ক দিবেন স্যার?
দিব, আমি একটু ব্যস্ত আছি, আজকে বা কালকে দেওয়ার চেষ্টা করব। আর সমস্যা হচ্ছে কি আপনাদের লেকচার মানে অনেকগুলো আপলোড করা হয়নি, তাই না?
জি স্যার।
প্রবলেম হয়ে গেছে এখন ডাউনলি আপলোড লিঙ্ক এত স্লো যে করতে অনেক সময় লাগছে। All right, guys, you can leave. Have a nice weekend. Take care.
Allah Hafiz, sir. Assalamu alaikum.